Okay, so the next thing, of course, is to analyze the M+1 peak, right? So for methane, the M+1 peak is, so remember, methane is, I guess got a picture of it right there, don't we? 12 plus 4 is equal to 16, right? So the molecular ion peak is 16. Boom, right there, and that's the base peak. But the M+1 peak is here, right? Why do we have some methane that weighs 17? That's because 1% of all carbon atoms are carbon-13, right? And so that's what gives the M+1 peak in methane. All right, so the more carbon atoms in a compound, the more abundant the M+1 peak is because it's a ratio, right? So if 1% chance that there's 1% chance that any carbon atom is going to be carbon-13, if you have more carbon atoms, then it increases the ratio. So for decane, this ratio is about 10 to 1, right? Decane is C10H22, okay? And so the molecular ion peak is here, right? Because C10H, is 10 times 12 plus 22 times 1 is equal to 120 plus 22 is equal to 142, right? And that's here, okay? But 1% of these carbon atoms are carbon-13, and since there's 10 of them, this ratio is going to be about 10 to 1. So comparing this M+1 peak is M+1 to the M plus peak is going to give you a rough estimate of the number of carbons. I should say rough estimate, let me say it like that, because we're oftentimes not going to actually have that number. But you can see that's consistent with 10, right? And this is where this is 10, and that's 100. So that's a decent estimate, and I think that's all we're going to say about the M plus peak.